Thank you very much. So our team is the Transportation Junkies, and obviously, like everyone, what we noticed about the data set we have, it's extremely high spatial resolution, so we wanted to compare to other data sets with high spatial resolution. And so for that, what we did is we compared against the small area data from the 2016 census, where we have many hundreds of different categories we can compare against. And then we would use the same polygons that cover those small areas to compute the pollution inside those areas. We made important use of BigQuery in order to do this efficiently. And then we could ask many different questions depending on what we're interested in looking at, basically. So so this is the area. We have about 2,000 polygons that divide up the city, and we have about 500 people living in each one, and we can ask different questions like what we're going to look at in particular is how many children are there, or you could also ask about social, economic background and things like that. So first thing we did is we had to cut up all the polygons and then send it off and compare it to the air quality data set. What we chose to focus on was children, because what we don't want is lots of pollution in areas where there's also lots of children living. So here's a map, a density map of the children living in the city. In the middle, you don't see many children. It's more of a business district, and families tend to live further out in the city. Very few people live in Phoenix Park, it shows, which is good. It's consistent, at least. Then we take the air quality map, and we just average the pollution in each of those polygons. So that's a big calculation, but thankfully BigQuery was able to do it for us very fast. And these are then this is where the more polluted areas are in the city. And then I'll hand it over to Cillian to discuss the results.
Great, thank you very much. I'm already regretting the name we chose, but yeah, so here are the results of our analysis. And the dark red is basically where we saw high correlation of high density of children, as well as high density of pollution of NO2. So our use of this data would be to really look at these areas and find ways in which we can possibly improve the way it's planned. So one of the main concerns that we found is usually traffic lights. So cars staying idle in these streets really increases the air pollution. So either finding ways to reroute traffic or really creating an atmosphere in the city in which cycling, walking around, taking public transport is really incentivized. Great, so this is what the data we used to find a correlation between the traffic speed and the CO2 levels in the atmosphere, and there was a positive correlation. If you look on the left-hand side, 0 is when the car is idle, and yeah, we really saw that was what we assumed, but this is a proof of our assumptions. And really, the way we're looking at it is how can we use this data to either help Dublin City Council or look at the next steps that we could do with this analysis. So an interesting thing we looked at is looking at different points and areas within our maps. So here we looked at power, basically, yeah, power stations within Dublin, and looking at the levels of pollution. But this, we can look at schools, for example, Crumlin School, where there was a lot of construction, and see what's the level of pollution there. Is it really correlating with the amount of children? Because the children we've looked at where the children were living at, but during the day they'll be going to school, going to different areas. Well, okay, perfect.
Good stuff, guys, yeah.